and how it works. Magnetic flow meter is an instrument which uses a magnetic field to measure the volume of fluid which is flowing through a pipe in a set period of time. A magnetic flow meter is also known as electromagnetic flow meter or mag meter. They do not have any moving parts. They are obstruction-less, cost-effective, bidirectional and provide highly accurate volumetric flow measurement. They are suitable for a wide range of pipe sizes and can be used to measure flow rate of only conductive fluids. Parts of magnetic flow meter. Electromagnetic flow meters consist of a sensor and transmitter that together works to measure flow. The sensor is placed in a pipeline and measures the induced voltage generated by the fluid as it flows through a magnetic field. The transmitter takes this voltage generated by the sensor and converts this voltage into a flow measurement and transmits that flow measurement to a control system. Magnetic flow meter typically consists of two electromagnetic coils that are mounted on opposite sides of a non-magnetic flow tube. These electromagnetic coils produce the magnetic field, and this magnetic field has to permeate the process liquid through the flow tube wall. And due to this reason, the flow tube should not have magnetic properties. So non-ferromagnetic flow tube is used. The inside of the measuring tube is lined by an insulating material such as rubber, neoprene, etc., which is resistant to the properties of the fluid, and the liner should be non-conductive. Two electrodes are fitted inside the tube to detect the voltage generated by the conducting fluid. Operating principle of magnetic flow meter. The operation of a magnetic flow meter or mag meter is based on Faraday's law of induction. Faraday's law of induction states that the voltage induced across any conductor as it moves at right angles through a magnetic field is proportional to the velocity of that conductor. In magnetic flow meters, electrically conductive flowing fluid works as the conductor. So according to Faraday's law, when a conductive fluid flows through a magnetic field, it generates voltage. When the conductive fluid is flowing more quickly, more voltage is generated. The voltage generated is proportional to the velocity of the flowing fluid. Working of a magnetic flow meter. Consider that we have installed a magnetic flow meter to measure volume of a conductive fluid flowing through a pipe. A conductive fluid contains positively and negatively charged ions. The flow of these ions conduct electricity through the conductive fluid. These charged particles are evenly distributed in the fluid. When a current is applied to the electromagnetic coil, they generate a constant magnetic field across the cross-sectional area of the flow tube. This magnetic field applies a force to the charged particles, and as a result, the positively and negatively charged particles in the fluid get separated and collect on the opposite sides of the flow tube. Now an electrical voltage is formed. This electrical voltage is picked up by the electrodes and is sent to a transmitter which is either mounted on the flow meter or connected remotely. This induced voltage will be proportional to the velocity of the fluid in the pipe. Knowing the velocity and dimension of the pipe's cross-section, flow volume can be calculated. By this, we come to the end of this video. If you like this video, please don't forget to subscribe the channel and support us. Thank you.